In this tutorial, we're looking at volume and surface area. Volume is the space inside a three-dimensional shape. Imagine if you've got a water bottle and you are filling that up with water, that is the volume, whereas the surface area is the area of all the faces added together. How to work this out? We're going to use a formula for volume to begin. Now, there is a formula to find the volume of prisms. And a prism is any three-dimensional shape. You find the area of the two-dimensional cross-section, and we'll talk about what this means shortly, and you multiply by the depth. Now the units of volume will be things like centimetres cubed or metres cubed or millimetres cubed, etc. So let's look for the case of our cuboid. Now 2D cross-section, what that means is if you were to slice your three-dimensional shape like a loaf of bread, what two-dimensional face would you always see? In this case we would see our rectangle. So if we were to call this the length, this the width and this the depth, how far back it goes, to find the area of your rectangle you would do length times width, and then to find the volume you times it by the depth. So this is specifically for a cube or a cuboid. Just to note, if you were finding the volume or the surface area of a sphere or a cone, you would be given the formulas to do so. Now let's look at the volume for our triangular prism, so think of like a Toblerone. The 2D cross-section, what two-dimensional shape would we always see? We see the triangle. So if we've got this, which is the base and the height and then the depth, the volume, to find the volume of a triangular prism, we're going to do the base times the height divided by 2, which is the area of a triangle, and then we multiply that by the depth. So it's not just one formula fits all, it's not just length times width times depth. It depends on the three-dimensional shape that you've got. Let's look at a cylinder. The two-dimensional shape we always see in this case is a circle. To find the area of our circle, that's pi times the radius squared, pi r squared, and then we multiply that by the depth. It might be called the height in the exam question. It all depends on which way your shape is kind of standing. This is kind of what we call a composite shape. So let's just put some numbers on here. So let's call this 10 centimetres, 2 centimetres, 6 centimetres, 3 centimetres. So what we want to do here is identify our 2D cross-section, which is going to be this L shape. And let's say it's got a depth of 5 centimetres. Now what we want to do, so that one there is 2. So what we want to do is find first the area of our 2D cross-section. Now how best to do this is to break it up into two shapes, which we will call A and B. So area of A is 6 times 3, which is 18 centimetres squared. Area of B, now remember the base is not 10 because this section here is 3 centimetres, which means this section here is 7 centimetres. So that's 7 times 2, which is 14 centimetres squared. Our next step is adding together the areas of the face, so 32 centimetres squared. And now we times that by the depth to find the volume, 160 centimetres cubed. So that is volume. Next we look at surface area. Surface area, really you just want to visualize that three-dimensional shape and identify how many faces that shape has. So what we're going to do here is we'll call them length, width and depth. Rather than learning a formula, obviously just understand how to do the process. So our face here, our yellow highlighted face, we do have one at the front, but we also have one identical at the back. So that is length times width to find the area of our face, but then we're going to times that by 2 because we've got one at the front and one at the back. Then we have a top and a bottom, to which we do the length times the depth. See, length times depth, and we've got 2 of them. Next we look at the 2 sides. So we've got a left side and we've got a right side, which is base times height or length times width. In this case that's the width times the depth. So we go 2 times width times depth. So that would be our surface area of cuboid. In this case it's very similar. All you want to do is identify your faces. So you've got a triangle at the front and a triangle at the back. You've got a base, which would be base times depth in this case. You've got a back section, and then you've got almost this slanted face here, of which you would need to know this length, because then you'd be timesing it by this to find the area. So sometimes Pythagoras comes into it if it's a right angle triangle. Surface area of a cuboid, what I want you to imagine is a baked beans tin. So you've got the top and the bottom of that baked beans tin, to which you would do, so surface area, you would do pi r squared, and then you would times that by 2 because you've got one at the top and one at the bottom. Now really visualize your baked beans tin and the baked bean tin wrapper, and unravel that wrapper. And what shape is it? What you'll see is a rectangle, where one of the lengths of the rectangle is the depth. So our rectangle, and we've got our depth, and then the other length of that rectangle is actually the circumference of your circle, to which you would have to do pi times diameter to work that out, and diameter is twice the radius.